Hello, my name is NICKYSTANLEY MERIDIN. My metric number is 221061108. So I will explain about the introduction. So we will building a 5 megawatt solar PV farm in Malaysia Perlis. So as you know, Perlis is one of the hot place in Malaysia. So it's suitable for us to build a solar PV farm. So the building The development of the solar farm in Perlis or Unimap Perlis will provide hands-on learning and research for the student and also the staff, so they can learn on how the system operate and how to do the maintenance. So SBU Power Sdn Berhad leads the development with Tenaga Nasional Berhad, ensuring connectivity to the national grid. So that is for the introduction. So this is the objective. We have 6 objectives. So the first one is design, install, and commission a 5 megawatt solar PV system to produce clean renewable energy. So the second is the support national energy goals. Third, help reduce greenhouse gas emission and support Malaysian effort to combat climate change. Fourth is offer a reliable and sustainable source of power to Unimap. After fifth, the next is demonstrate site for the renewable energy technology, supporting and research development and educational community at Unimap. And the last one is providing training for the Unimap staff and also the student in solar energy system and the operation and maintenance for the solar energy. So let's go to the project scope. So the project scope is also we have a 6. The first one is land preparation and site survey, design and engineering, monitoring and maintenance, procurement and installation, grid connection and integration, and testing, commissioning and handover. So this is the project scope of our uh, for our 5 megawatt solar PV farm. So let's do to the most important is the project specification. So here we divide into a 6. So the first one is location. The location of the 5 megawatt solar PV farm is Unimap land area, which is in Perlis. So the total capacity for the solar is 5 megawatt DC. Why a DC or direct current? So the grid connection voltage is 30 kV or as the per local grid requirement. So here we will refer to the TNB. What is the local grid requirement for the in the area or in the Unimap area. So the next is inverter. So string or central inverter with MPPT. What is a MPPT? MPPT is a maximum power point tracking. So it's capable to optimize energy conversion efficiency. So which means we invert the solar or the light from the sun to the energy, like to the current or the voltage. So we convert from lightning to the current or voltage, so or the power. So next is expected energy output. So we expect the 5 megawatt solar PV farm produce 65000 kilowatt annually. So but it's depend on the local solar irradiation condition lah. So the last one is the duration of the project. So we estimate 12 or 18 months for the planning and from the planning and the approval to the full commission lah.
Thank you, Nikki, for the previous for your introduction, your project scope, your project objectives, and your project specification. So now I will take over the list of activities, descriptions of activities, and resource requirement and budget estimation for the required project. So as we can see here in the list of activities, a detailed list of steps necessary for the useful installation of 5 megawatt solar photovoltaic PV farm under the large-scale solar system program is provided in the following table. Effective project management and execution are made possible by including each activity's estimated length, predecessor activities, and successor activities. So from here, I have labeled all the activity ID from A1 to A15 along with its activity description, its duration, days, predecessor, and successors. So for A1, the activity is site assessment with a duration of 10 days, as it doesn't has any predecessor, but it has a successor to A2, which is feasibility study, has a duration of 15 days with the predecessor of A1 and successor of A3, obtain permits and approvals with the duration of 30 days with the predecessor A2 and successor A4, detailed project planning with the duration of 20 days with the predecessor of A3 and successor of A5, procurement of equipment 35 days the duration along with its predecessor and successors of A6 A6, which is site preparation 15 days along with its predecessor and successor of A7, and installation of mounting structures duration of 10 days predecessor of A6 and successor of A8, installation of solar panels with a duration of 20 days predecessor A7 and successor of A9, electrical wiring and connection with a duration of 15 days A8 as a predecessor and successor of A10, installation of inverters with a duration of 10 days predecessor A9 and successor of A11, connection to the grid with a duration of 10 days with predecessor A10 and successor of A12. So testing and commissioning with a duration of 15 days along with its predecessor of A11 and successor of A13. Final inspection and approval with a duration of 5 days, predecessor of A12 and successor of A14. Project handover is with a duration of 5 days with predecessor A13, successor of A15, and lastly operations and maintenance plan development with a duration of 10 days and predecessor of A14 and no successor, as is the final phase of our project. So now the description of activities for each A1, A2 until A15. So the first part is site assessment, so which A1 examines the proposed location in detail to determine the amount of solar irradiation and is shadowing from nearby structures and environmental impact factors. Determining the viability and effectiveness of solar energy capture requires this fundamental study. Second, feasibility study. Conduct a thorough feasibility study that includes environmental, technological, and economic studies through cost-benefit analysis, ROI, return on investment, and regulatory framework compliance. This study will assess the project's viability. Number 3, A3, obtain approvals and permits. Obtain all federal, state, and municipal permits that are needed for operation and construction to guarantee adherence to zoning and environmental standards. This procedure may entail discussions with regulatory agencies. A4, detailed project planning. Create a thorough project plan that includes budget estimates, schedules, resource allocation, risk management, techniques and procedures for engaging stakeholders. This document acts as a project execution road plan. Number 5, A5, equipment procurement. Start the process of acquiring the necessary equipment such as electrical components, mounting frames, solar panels, inverters. Careful vendor selection is necessary during this phase to guarantee quality and adherence to industry standards. A6, site preparation to establish a proper foundation for the installation of solar panels. Carry out site preparation tasks such as excavation, grading, and land clearance as needed in order to guarantee ideal installation condition. This step is essential. A7, mounting structure installation, put in place the mounting frameworks that will hold up with solar panels. For this step, to guarantee structural integrity and alignment with design criteria, engineering specifications must be followed. A8 solar panel installation, continuing attaching solar panels to mounting frameworks to optimize energy capture efficiency and guarantee that safety procedures are observed. This task necessitates accuracy. Connecting an A9, connecting solar panels to inverters and other electrical components requires the use of electrical wiring. Electrical codes must be followed throughout this phase to guarantee functionality and safety. Next, installing inverters. Install inverters that transform solar generated direct current DC current into AC current that can be used on site or connected to the grid. Grid connection, connect the solar PV system to a nearby electrical grid while following the utilities interconnection agreement criteria. Testing and commissioning. A12, make sure all systems operate as planned by carrying out thorough testing processes. Before granting full operational status, commissioning makes sure that performance measures fulfill predetermined. Final examination and approval, conduct a final examination to verify adherence to the project specification and all the legal requirements before the project is turned over. Get official approval from the appropriate authorities. Project handover, formally turn over ownership of the finished project to customers or stakeholders, supplying all required paperwork including maintenance schedules, warranties and operation manuals. And the last part, A15, development of an operations maintenance plan. Create a thorough operations and maintenance plan that details post-installation performance optimization techniques, maintenance schedules, troubleshooting techniques and methods for continuing system monitoring. Next, we will follow more with the resource requirement and budget estimation. So in the resource requirement and budget estimation, the resources required for the site assessment is surveying equipment, environmental assessment tools, personnel, engineers, environmental scientists, which has an estimated cost of 45,000. A2 with the feasibility study, financial analyst, technical consultant, software for modeling and analysis, which also has an estimated cost of 67,500 based on the current market value. And A3, legal advisors, permits, application fees, administrative staff with 90,000 estimated cost. And also A4, project management software, planning team, project managers such and engineers, which also has an estimated cost of 54,000. And A5, contract with suppliers for solar panels and inverters logistics for delivery, which has about 6,750,000, followed by heavy machinery for the site preparation, excavators, graders, labor force for the site clearing, 225,000. Mounting hardware, steel frames, construction crew, tools for installation, 450,000. Solar panels, approximately 15,000 panels, installation crew, safety equipment, which has an estimated value of 5,400,000. Next, followed by electrical cabins, cabin connectors, electrical cabling connectors, electrical engineers and technicians, also has an estimated cost around 360,000. Next, with the installation of inverters, approximately 5 units, installation crew and testing equipment, also estimated around 450,000. Connection to the grid, interconnection, materials, transformers, coordination with utility companies, which also has a estimated value of 225,000. And testing and commissioning, testing equipment such as multimeters, load testers, commissioning engineers such as 135,000. And the last part, final inspection and approval, inspection team, certified inspectors and document preparation, about 22,500. When we also A14, project handover, administrative staff for documentation and training sessions for operators, also estimated value of 22,500. Operations and maintenance plan, maintenance team, planning sessions and documentation resources, about 45,000. So the entire estimated budget as the solar PV farm project is expected to cost around 13,725,000 in total. This budget compromises both direct expenditures for labor and materials, as well as indirect costs like consultation fees, and it covers all the necessary operations from the first site assessment to the project handover. So that is all from my part.
Okay, thank you, Jeevan. Okay, my name is AHMAD AMIRUDDIN bin SUHAIMI. Normal metric 229291092954. Okay, I will proceed with project master schedule and linear responsibility chart. So first, we look at the project master schedule. As we can see, this is the task name. We group it into three group, into phase 1, phase 2, and phase 3. This is the duration. Okay, we start at 1 January and end at 27 September. So we can see that the dependency is A1. Okay, A2 start at A1 and A3 at A1. So this, we can use it to more clearly look at it when we use A or N. So this is the right side is the team involved in every task. So to look it more clearly, the responsibility chart. So as you can see, this is project manager. So project manager need to work at all of the tasks, need to see all the progress on of the task, so they can monitor it. So next, this is the roles, the meaning of PM, SAT, FST, PT, everything. So A, responsible, accountable, consulted, informed. So we can see that PM change their for at phase 1, it does A1, A2, and A3. PM project manager is A, so is accountable, ultimate answerable for the test. So if you have a problem, you can ask project manager for all the tasks. So as you can see that every task is different. Every as you can see that their job is different. So yeah, project manager need to cover all the expenses and all of expenses, but it need to control the expenses. Okay, next is activity or not. I already tell before that we can see it more clearly with A or N, activity or not. So okay, as you can see, A1 uh, is the first task, and A2 and A3 branch off from A1. Yeah, this dependency. So you need to clear A1 first to proceed with A2 and A3. But for A4, if you want to proceed with A4, you need to clear A2 and A3 first. So it's take more time lah. So as you can see, this is the perfect example of linear process flow graph, but only have these branches. So we start it at 0 at first day until we take it around 195 days total to complete the project. So we use activity or not for purposely find a float day or slack days. Slack days mean free time, like lebihan masa lah, lebihan hari. So we can find it by LST minus EST and LFT minus EFT. So usually they will give you same same answer lah. So as you can see that this is EST, EFT, LST, and LFT. So we just need to minus them to find the value of the slack days. As you can see, A2 have 5 slack days because you can see 30 minus 25 and 50 minus 10. This means that A2 is the most what we call a slack, the only one that have slack days. So from A or N, we can also find the critical path. It's 1 to first task until A15, the last task, but the critical path is A1 to A3 because A2 has slack days, so it's not really a critical path. Next, so the minimum time duration is 195 days. So this is our timeline project. So as you can see, phase 1, phase 2, and phase 3. Phase 1 is planning. So planning is more to the office, and site assessment it will be given to the site. As you can see, yes, site assessment team. So SAT, they will scout the site first, and from there they have to they find the data and they bring to meeting about to make sure the project is um, fluently conduct. So planning, so it takes around 2 months, and phase two execution. So this is the more to the on-site job. So this is belong responsibility of um, yeah, responsibility from this PTM, CT, IT ni semua. PTM ni yeah, procurement team, construction team, installation team, electrical team. So they will do their job on site. But and phase three is closing. So phase three is more to testing part, final inspection, project handout. So but the difficult, so this is different aspect of job. So different people, but project manager need to always active in this project to judge or make precaution for the final project, so the final outcome. So I think that's all from me. So I will pass it to Hazwan to briefly example of our discussion.
Assalamualaikum, my name is Muhammad Hazwan bin MAHDZIR, nombor metrik 2210936662. Okay, thank you for the previous presenter. Now my turn to present about discussion about our project 5 megawatt solar PV. Okay, for the discussion we have discussed about the impact. For the first impact is environmental impact. For the environmental impact, I have divided for 3 points. For the first point is reduction of greenhouse gas emission. Solar energy reduce greenhouse gas emission, helping combat climate change. 5 megawatt solar PV system can cut 260,000 tons of carbon dioxide annually, equal to removing thousands of cars. Support Malaysia climate goal under the Paris Agreement for a 45% carbon intensity reduction by 2030. Promotes cleaner air and reduce reliance on fossil fuels. Second point is conservation of natural resource. Solar energy use the renewable power of the sun, reducing dependence on coal, oil and gas. Minimize environmental damage from fossil fuel extraction like habitat loss and water pollution. Ensure sustainable energy generation, protecting ecosystem for future generation. Third point, land use and biodiversity consideration. Solar farm needs careful planning to minimize land and biodiversity impact. Environmental impact assessment help address and mitigate ecological effects. Agrovoltaic farming with solar panel balance energy production with agriculture. Buffer zone and low impact site selection preserve biodiversity and reduce disturbance. Okay, next, for the impact we have social impact. For the social impact, first is job creation and economic development. Can create job during construction in project management, engineering and construction. Renewable energy project generate more job per power unit than fossil fuel. Offer long-term job for solar farm maintenance and monitoring. Boosts local economies and build expertise in renewable energy. Second point, research advancement and educational opportunities. Provide hands-on learning for UNIMED students, especially in engineering and environmental science. Encourage research collaboration to improve solar technology and assess socio-economic impact. Enhance student knowledge of renewable energy. Inspiring sustainable innovation. Position UNIMED as a leader in renewable energy education and workforce preparation. Okay, next we have raising awareness and involve the community. First, engage the community by involve stakeholder in renewable energy discussion. educational program increase awareness of solar energy benefit and climate change mitigation. Establish UNIMED as a sustainability advocate, inspiring green practice. Promote community involvement in renewable energy project, creating a broader impact. Okay, next. For the conclusion for our project, okay, first, environmental impact. The 5 megawatt solar PV farm reduce greenhouse gas emission, support Malaysia Paris Agreement goal, and reduce reliance on fossil fuel. Biodiversity prevention. Proper design ensure minimal ecological disruption, proving that renewable energy development can align with environmental management. Economic growth. The project create job opportunity during construction and operation, contributing to local economic development. 4. Educational benefit. The solar farm serve as a living laboratory for students, promoting innovation in renewable energy and preparing them for future career. Community engagement. The project foster community involvement, raising awareness of sustainable energy practice, and encourage broader adoption of renewable solution. Okay, that's all from me. Thank you.